So last time we discussed continuous and graded exercise, and this part we're going to discuss efficiency. So in order to measure efficiency, we need to look at amount of work done in an ergometer, we need to measure oxygen consumption with a metabolic cart, and we have to achieve steady state. So once we've done those three things, we have all the information we need to calculate efficiency. So let's define it. Efficiency can be defined as the ability to use the total energy that we produce, okay, derived from metabolism, in order to do mechanical work. So what does that mean? Well, if it's total energy derived from metabolism, we're talking about ATP production. And if we're working aerobically, okay, that is submaximally, where we can achieve a steady state, what we see is that that's highly related to the volume of oxygen consumed, okay, in liters per minute. Next is work. So work, remember down here, is equal to a force times the distance. And we can measure that with an ergometer. Okay. And if we have an ergometer and we're applying a force, what we have here is our muscle. And it's contracting. And it uses ATP. So on the one hand, we can see the work being done by our muscles as a measure of ergometry. And on the other hand, we can see how much our metabolism is producing ATP based on our expired air. Now what we find with efficiency, okay, gross efficiency, which is the work divided by the total energy, it's always going to be between about, let's say 5 to 20% efficient, which means that out of all the ATP that we produce, only 5 to 20% of it is going to be used on the ergometer, which means that, let's say 95 to 80% of it is liberated as heat. And again, heat is a form of energy. So that takes us to the whole topic of thermal regulation, which we'll cover later on. But it's important to remember there's always that balance. We are never particularly efficient as human beings. Okay? We're never going to achieve an efficiency of 100%. We're always going to generate a lot of heat, which is actually helpful to us in some ways, but it means that we are limited. So let's break this down. The equation is going to be work divided by total energy. So how do we come about those two numbers? Well, first of all, total energy, like we said, is coming from the amount of oxygen we've consumed. So if we have liters of oxygen measured by the metabolic cart, we also have liters of carbon dioxide measured by the metabolic cart. Then we can calculate RER. RER will then tell us how much energy we're using based on an RER table. And then we can multiply that number by the volume of oxygen, and it will give us energy. On this side, we need to use one of our equations. So let's say work is equal to force times distance. If we have force and distance, we can calculate work. Now we also could use the equation of power output times time, because power output is equal to work over time. So which one we use depends on the variables we're given. To look closely at the question to determine if you can calculate force and distance, or maybe you're given power output and time. Either way, you're left with energy. So the final piece we're going to cover in this video is what is energy. Well, there's a special consideration in that here, energy, the units, is in joules. Whereas at this stage, typically we're going to be in a unit called kcals. So kcals are equal to the energy it takes to change water 1 degree Celsius. And there's a conversion for that, which is, let's do it in someone special color, 1 kcal is equal to 4,185 joules. So we'll stop there. We'll come back with a problem and we'll do the math.